Alright, good evening. This is your video lesson just in case the notes go too long and we can't finish them because of our CASP testing. So I'm going to go ahead and make these quick videos, try to give you some extra help. So quick review on what we did last time. We talked about tangency lines, which we say that it is a line to a circle, or a tangent to a circle, sorry. And what happens with this line is it intersects the circle at exactly one point. We call that point the point of tangency. So in this case, AB is a tangent line. We can say BA is a tangent ray. And then AB is a tangent segment. Now, our tangent circle theorem goes like this. We say that if a line is tangent to a circle, then the line is perpendicular to the radius. So if I have a tangent line, boom, then no matter where the radius is, if I draw it to the point of tangency, that will always form a right angle. And this will allow us to do several properties. We can work with right triangles, which will then allow us to use the Pythagorean theorem. Or depending on what other shapes we create, we'll use those particular properties. So in example 1, we know that ML and MN are tangent to our circle. So right away I know, hey, these two spots here form right angles. I wish to find the value of x. The overall shape that's going on here is a quadrilateral. If you remember that the interior angles of a quadrilateral all add up to 360, we can then say x plus 90 plus 90 plus 117 equals 360 degrees. So we say x plus, when you add those up, you should get 180, 297 equals 360. If I make a mistake, fix it. I trust you. Let's go ahead and subtract 297 from both sides. So then x equals 63 degrees. And there you go. Not too bad. Just using the same stuff you know before. Now, on example 2, we're told that ED is tangent to the circle. So right away, you should make a right angle. Find the value of x. Well, my overall shape in this figure is now a triangle. So that means all three angles have to add up to 180. So again, simplify your expression. X plus 128 equals 180. So when you subtract the 128 from both sides, you should get x equals 52 degrees. Example 3, assume that lines that appear to be tangent are tangent. O is the center of the circle. Well, the only information I've really given you here is the tangent line. And that tells you, hey, I have a right angle here. Well, if you remember from the last lesson, I told you all about how crucial it is to be able to identify your radius and be able to rewrite it in different parts of the circle. So this radius here of x is the same radius here for x. So we're going to say that this is x. And now we can say that the total length here is x plus 7. Now this is crucial because if you remember, I told you all that we're going to be doing the Pythagorean theorem a lot. Well, there's my right triangle, so we can actually go straight ahead to it. X squared plus 12 squared equals the quantity x plus 7 squared. If you don't remember what to do for that right-hand side, just a little quick revisit. When you're squaring something, that's equivalent to multiplying it by itself twice. So this is where you would FOIL. You would do the first times the first times the last, the second times the first, second times the second. And so, without going into too much detail, you get x squared plus 7x plus 7x plus 49, which simplifies to x squared plus 14 plus 49, 14x. So x squared plus 144 equals x squared plus 14x plus 49. Clean that up. Okay, so now at this point we're going to try to subtract the x squareds from both sides, and you'll notice since there is an x squared on each side, they're simply gone. So I have 144 equals 14x plus 49. Let's go ahead and subtract that from both sides. So then I have 14x equal to 90, gosh, why can't I math? 95, I think. Yeah, 95. So now you're going to go ahead and divide both sides by 14. Now, I don't believe 95 and 14 simplify at all. So, you can just simply leave your answer as the improper fraction. There will be some instances where you can have an improper fraction. Other times you won't have an improper fraction. And in this case, we do. If I wanted to change the numbers up a bit, I could totally make it possible where we do end up with nice numbers. But if you don't, just keep it as an improper fraction. Don't even bother trying to write it as a decimal. Okay? Cool. Here's your next theorem. It's the converse of it. Now, this one's not as straightforward as the other ones. This one is more kind of like what we did with the converse of the Pythagorean theorem, where we said if the a squared plus b squared side was greater, then you had an acute triangle. If the c squared side was bigger, you had an obtuse triangle. This one's similar, but you don't have all those conditions. You just have the one where if you have a line that's perpendicular to the radius, then the line becomes tangent. So what we can do is we can prove whether a line is tangent or not by simply showing that it has to be perpendicular. And the easy way of doing that is, again, your Pythagorean theorem. So right here on example 4, I ask you the question, is ML tangent? So here's ML. I want to figure out, does there exist a right angle here? And the way we prove that, we're going to use the Pythagorean theorem. Some of you might recognize these numbers. And these numbers are actually, again, Pythagorean triples. So what will happen is after you do your work, you do get 625 equals 625. Since that statement is true, we say yes, ML is tangent to circle, and you can put a little circle with a dot in the middle to circle N. And in terms of your explanation, your work is all right here. No need to do anything extra. All right. Now on example 5, NL equals 4, LM equals 7, NM equals 8. So we're going to check if this line is tangent to N. So let's see here. We have our 4. We have our 7. NM is 8. So we're going to go ahead and check. 4 squared plus 7 squared. And I'm going to put a question mark above here. Does this equal 8 squared? And we're going to check right now. 16 plus 49. Try that again, Mr. T. 64. So then I believe that gets us 65 on the left-hand side, which does not equal 64. So therefore, ML is not tangent. Oh my gosh, I can't try it right now. And that's all you have to do. Let's see here. Actually, okay, so now I remember what this is. You actually did not get to learn all of these because of the way we redid the curriculum. But something that is a property about circles is that if you take any triangle and you were to find the mid-segment, I believe, no, the perpendicular bisector of each one, they all meet at a point, and that point becomes the center of a circle that crosses through all corners of the circle. The triangle is inscribing the circle. Now, what happens is the opposite is that when the circle is inside of the triangle, we say the triangle is circumscribed about the circle. And so what happens is we're going to be using this property later is that you create all these tangent lines. So at this point here and here, you have two tangent lines that we're going to prove later are actually congruent to each other. And likewise, for all the rest of these, you're going to have congruent segments that are tangent. So these two lines are congruent, as well as these lines. You can also make the congruent markings if you wanted. You could say single, single, double, double, triple, triple. So the easiest way of remembering is that the corners of your triangle or whatever gets inscribed or circumscribed are going to end up being congruent in those spots. Now, I told you all last time that we were going to talk about what happens when you have two tangents, and it's super easy. Two tangents are always congruent when they meet the same circle. So in other words, they're equal. Yay. So you don't need to do any fancy formulas, just you know they're equal. So we can apply that here to this example 6. And you have to know that the circle is inscribed. So our circle is inscribed in the triangle. So automatically I know, hey, these two are equal because they are tangent lines. These two are equal. They're also tangent lines. And lastly, these two. So if this segment is 10, that means this segment is also 10. If this segment is 8, that means this side is also 8. And lastly, this is 15, so this side is 15. Now, in terms of the context of the question, it says find the perimeter. So that means I'm going to do 10 plus 15 to give me 25. 10 plus 8, which is 18. And lastly, 15 plus 8, which is 23. So then we're just going to add up all three of those. So my perimeter will equal 18 plus 25 plus 23. So I believe that's going to give us a nice 66 centimeters. Last one. Circle C is inscribed in your quadrilateral. So now in this one we have a four-sided figure. That's okay. We can still use all our properties of our tangent lines. We got to be a little careful though, because we got to make sure we don't accidentally do anything dumb or really silly. If I take a look here and I see this 14 is actually describing this entire length here. Do not automatically assume you can take the 14 and split it in half. That's not how this works. We have to work our way backwards. We have to go with the information we do know and work our way forwards from there. So if we take a look at this 8, this part is also 8. Well, if the entire length is 14, then that means this section here, which is green, that should be 14 minus 8. So that's going to be a length of 6. Which then means that this part is also 6. Now since I have the 2 there, that 2 is congruent to that part there. So that is a 2. Last but not least, we have our 11, which is congruent to this part here. And so again, going back to the problem, what am I finding? I'm finding the perimeter. So I'm going to add up all my side lengths. Now the 14 that's up there is still what I need, so that's my 14. 11 plus 8 is 19. 11 plus 2 is 13. And 6 plus 2 is 8. So I'm going to say that my perimeter equals 19 plus 14 plus 8 plus 13. So that is 22, 35, 44, 54. So that's going to be 54 feet. And that concludes our very quick lesson of, why can't I remember? 10.3. 10.3. It's really late, guys. It's 10:53, and I still got one more video. So I'll catch you in the next one. Again, let me know if you have any questions or anything that you need help with. All right? See ya.